Welcome back, I'm that chemist, and today we have a story where somebody dumps out their chemical waste in the middle of the ocean. On the subject of safety goggles, it reminds me of a story from my very early childhood when I was young enough to ride in the front seat of a shopping cart. My mom was going through a cleaning supplies aisle when she stopped to either look at something or talk with someone. What I vividly remember was my thought process at the time. I was very curious about what a spray from a spray can looked like when you looked directly into the nozzle. Again, I was probably around 4 or 5. Needless to say, I found out the hard way what a terrible idea that was. Partly thanks to an employee, I didn't receive any lasting damage to my eyes. I'm actually one of the only people in my family that doesn't need glasses. Yet. Probably a good lesson about keeping a watchful eye on your kids, as you never know what sort of trouble their curiosity could lead to. So, one curiosity story I have was from when I was younger. I think I was like a teenager at the time. I was definitely old enough to know better, but I was young enough that this kind of stupid stuff still happened. So I got this plasma globe from when I'd visited NASA, and for whatever reason the plasma globe wasn't working. This is actually the same plasma globe that was in my pink chemistry video. And it wasn't working, so I figured maybe if I licked the contact, that would make it more conductive. So I did this while it was plugged in, and I got shocked. And I didn't die, even though it had already gone through the small transformer to become a higher amperage. So that was pretty dumb. What did I learn? Don't lick electrical contacts, I guess. I don't know. It was pretty stupid. And anybody who's heard this story was like, yeah, that was stupid. You're an idiot. When I was a kid, I had an absurd interest with zinc. I would literally hoard all of the pennies in the house. For those who are curious, many pennies are made of zinc and they're just copper plated. I would literally hoard all of the pennies in the house and sandpaper away all of the copper so that I'd have the pure metal. One day I thought it was a good idea to melt the zinc, but without a furnace, the next best thing was my parents' stove. I put about 7 grams of pennies on a spoon and started heating. Eventually I had a slag, but nowhere to pour the metal. In my childlike knowledge, I put the red-hot steel spoon directly on my parents' countertop, burning a sizable hole. I was so scared and hid the hole with a fruit basket and cleaned the whole house because I was a good boy. I did eventually get caught, but they weren't harsh on me. So I eventually did it again, making a similar mistake, except now near the sink, and this time I learned my lesson when my parents found out what was underneath the fruit basket. They forgave you the first time, but they did not forgive you the second time. Stockroom lab tech told me a story once from her previous place of work. Maria worked in a lab with Johnny, who is a bit kooky, and probably had no business being anywhere near a lab. One day she heard a loud crash from the other side of the room where Johnny had been working. She sees that a 4-liter glass bottle had smashed on the floor, and its contents were everywhere. Johnny begins trying to soak up the large spill of unknown substance as Maria evacuates the room immediately. From the doorway, Maria asks Johnny, "What is it that you spilled?" And with Johnny hunched over the chemical spill, he reads the label from the broken bottle and says, Pyridine. Maria repeats the word and asks herself what it could possibly be. Moments later, she realizes that the chemical is pyridine. She immediately signals for Johnny to get out and proceeds to call for help. Pyridine is a terrible smelling compound. How toxic is pyridine? It's kind of toxic. If you spilled a whole 4-liter jug of it, that's definitely terrifying. That is way more pyridine than you ever want anywhere in a lab. I think in all of my research ever, I've probably used less than a liter of pyridine combined. Definitely an unpleasant experience. In my first year of undergraduate research, I had my own Schlenk line so that I could perform air-sensitive polymerizations outside of the glove box. A Schlenk line is just like a double vacuum line where one side is a nitrogen line and the other side is a vacuum. So with one stopcock, you can switch between nitrogen and vacuum so that you can evacuate an apparatus and backfill with nitrogen. So in this case, what they were likely doing is getting rid of the air and just replacing it with nitrogen so that they could have an air-free polymerization, as the presence of oxygen could impact the polymerization, which might be undesirable for their chemistry. It was really late one day, and being new and inexperienced, I turned off the vacuum pump without lowering the liquid nitrogen dewar cooling the trap. When you're using vacuum in a lab, one of the things we do to protect the vacuum pump is to put this cold trap, which is sometimes called a cold finger, even though that's technically a misnomer, and a liquid nitrogen dewar will go around that. And so the liquid nitrogen dewar will just condense any volatile gases or liquids that might get evaporated in the reaction setup. And that just prevents any of the organic chemicals from getting into the vacuum pump, which might wreck the pump. And so normally one of the things you do is after you turn off the vacuum pump, you're supposed to let air back in so that any pressure differences can even its way out. And so the issue here is that they still had their liquid nitrogen trap on the cold finger. Air can then go into the cold finger. And so what happened was oxygen condenses at 183 degrees Celsius, whereas liquid nitrogen boils at minus 196 degrees Celsius. And so as the nitrogen's evaporating out around the cold finger, liquid oxygen is able to condense in the trap. Now, it might not be entirely liquid oxygen. There might also be some nitrogen in there, so you're just condensing liquid air. But the issue is concentrated liquid oxygen is a really potent oxidizer, And so that trap that's trapped all the organics, which are likely flammable, are now in the presence of an oxidizer. So if there's any ignition source, that's going to go. So there's this atmosphere in most labs where safety is a concern, and liquid oxygen condensing in a cold trap is a concern that a lot of people have because it's happened to many people. The next morning I arrive in the lab and figure out that I condensed about 500 milliliters of liquid oxygen in the cold trap. I guess I'd had a leaky line. So they hadn't actually opened it, but somehow oxygen had got in through some sort of leak. Which essentially means that I've made a bomb that could blow up the whole lab, and maybe even more. Thankfully my mentor was able to take care of the liquid oxygen, but only after he took a picture of it in the trap, lol. So it's a question of context, right? You can have liquid oxygen in a compressed cylinder of oxygen, and that's fine, it's confined. But in this case, if you have concentrated oxygen in the presence of an organic, all it takes is the smallest spark, and that can all go, and it'll go fast. If you haven't seen liquid oxygen reacting with stuff, after you're done this video, I'd encourage you to go check out Chemical Force's channel, where he has done all sorts of experiments with liquid oxygen as well as liquid ozone. I'll include a link in the description if you're curious. My grandfather used to be a dentist. Sometimes he needed to test teeth for nerve decay. He did this by spraying a Q-tip with medical carbon tetrachloride, wiping it on the suspect tooth. The idea was that the carbon tet would be cold and activate a nerve response. As it's evaporating, it's going to cause a cooling effect really rapidly. If the response was instant, the nerve was dying. He used this method often. This was many years ago, and the toxicity of carbon tetrachloride was not yet known. So carbon tetrachloride is something you don't want anywhere near your mouth. It causes toxicity of the kidneys and liver. So this is a yikes, alright. Although it's not today's yikes awardee, you'll see who that is later. I have a story from when I was a dumb young student who didn't take labs seriously. Allergies were getting to my eyes, and I'd been lifting my goggles all day to rub them. We were working with concentrated sulfuric acid, and I didn't think much of it. I was about to rub my eyes again after I tested the pH. With one hand, I grabbed the litmus paper, and with the other, I lifted my goggles. At the last second, I noticed the paper was bright red from the insane amount of acid on my gloves. I think I should be blind. Thank God I randomly looked before doing something that stupid. You shouldn't be rubbing your eyes if you're wearing gloves at all, and there should be like a switch in your brain that flips that once you have gloves on, you're not touching your phone, you're not touching your hair, you're not touching your skin. You're not touching anything that you shouldn't be touching with gloves. When I've taught labs before, I see new students that don't develop this right away, but for me, there's such a clear distinction between when I'm wearing gloves and when I'm not that it wouldn't even happen that I'm touching some part of my body with the gloves that I wouldn't want to touch with contaminated gloves. It's just not within the realm of possibility. I think people get this idea because if you're like touching raw meat or cutting raw meat, you know like, okay, I have raw meat on my hands. And people are pretty smart about that. The exact same thing applies when you're wearing gloves. You just apply the raw meat mentality. Everything should be fine. If raw beef doesn't do it for you, just imagine raw chicken. Hopefully that does the job for you. I was in high school chemistry, and one lesson the teacher makes us all do a lab which involves investigating the oxidation of ethanol, specifically using a distillation apparatus so that we could collect the product. Anyway, when deciding on the oxidizing reagent to use, the teacher, head of safety on the school board, decided to break out the potassium dichromate for this particular experiment. So I get into my group and set up all my distillation equipment and the mixture before lighting the burner to start the experiment. Crucially, he said not to overheat the reaction mixture, as otherwise the reaction would be too aggressive. As I saw the thermometers laid out, I had the bright idea of inserting a holder into the top of the apparatus and placing a thermometer in it, because that was how it was laid out in the instructions, failing to hear my teacher say this wasn't necessary. So the issue here is they're about to heat a closed system, which is something I've done before, and it does not go well. After a little while, I turn away and tell my friend who's also part of this experiment to monitor the Bunsen burner, again, to prevent the reaction mixture from becoming a problem, aka a runaway reaction. My faith turned out to be misplaced when I turned back around after a few minutes and watched the thermometer holder be ejected into the ceiling by the gas pressure, along with everything nearby, including my skin, being sprayed with droplets of unreacted dichromate. Oh no! Chromium salts are carcinogenic. The stain in the ceiling is still there after over a year as far as I know, and because our lab didn't have any kind of safety shower, being a small local high school lab, I had to wash the orange stuff off me in the bathroom using some paper towels. Before this, I don't think I ever had a moment where I was truly thankful to be wearing eye protection, but I can safely say that was it. To make matters worse, the thermometer had obviously broken from the force, which had the teacher panicking about the mercury for a little bit, until we realized that it wasn't that type of thermometer. But after cleaning everything up, I was at least thankful that I didn't get any glass in me. I don't know if this one could have been avoided, but maybe the class could have been using a safer oxidant than dichromate. I think giving carcinogenic dichromate to high school students that aren't extremely supervised might be a little bit dangerous. Now, I've had it happen before where I had a gas outlet for a reduced pressure distillation, and it just didn't have enough flow rate through that glass adapter. And so as I was heating something with a heating mantle, or maybe it was an open flame, which is something you should not do, it ended up yeeting out my thermometer and it exploded into a million pieces. Fortunately, that was an alcohol thermometer, but it was sad because that thermometer had a ground glass joint and it was a really specialized size, and so we only had like one left after that. The last one that we had, I also broke, but it survived kind of. So the ground glass adapter survived, but there used to be this housing around the bottom where liquid would condense onto the thermometer. That one didn't break, but I was really careful after that happened. The other story is from my chemistry teacher herself. It happened back in the late 80s or early 90s, when some student told her that they had a bit of mercury in their house that was not in use by anyone, and that they could bring it to the class. Perhaps it could be used in some experiment. The teacher said sure. She assumed it would be a tiny vial of mercury from a broken thermometer or something like that. Nothing major, just a tiny amount that she could take, so that it wouldn't be hanging around some random house. The next chemistry class, the student brings the mercury to her, and it was not a vial. They brought a bloody mason jar full of mercury, and a large one at that. She asked them where the heck did they get the stuff from. They didn't know, it was just there in their house. And they asked their parents, who said they could have it, and bring it to the chemistry classes. My teacher is still shocked a couple decades later, and when this happened, she was especially terrified that the jar's bottom might break off at any moment, since, mercury is pretty heavy. She handled it carefully and handed it away to some laboratory her friends worked at to take care of it. She was not keeping all that garbage around. Large amounts of mercury are really scary. I was at a school once where it had previously been a school which was for high school students, and it ended up getting rezoned into a different type of school. And this classroom was being used for middle school students, except it wasn't a classroom, it was actually a decommissioned lab. And so this lab had chemicals that were several decades old, at least. And being a chemist, when I was visiting this place, I asked if I could have a look, and so no one had been in there for ages. And they had a giant ampule with mercury in it, and there was mercury salts floating on top of the mercury. That's just one of the things in this room. They had more lead powder than I've ever seen in my life. Like, we're talking different mesh sizes of lead powder, several kilos of it. And again, they had more potassium than I've ever seen in my life that was stored in, like, a sketchy looking fridge. So if you're in a school that has any old lab chemicals that haven't been looked at for at least a decade, you should probably get someone to look at that. Otherwise, you might have something explosive there just waiting to happen. We've included several stories from high school students where we've had, like, giant cubes of sodium, the type of stuff you don't want around kids, and maybe it would be worth suggesting to someone in your faculty to have a look at least, because you never know what's in there. You really don't know what monsters are under your bed. My dad told me a story about how back in his college days in a food science-focused microbiome class, the professor was out of the room, and he, the dad, was getting frustrated using a pipette bulb to move around some Staphylococcus aureus cultures. Therefore, he decided to mouth pipette them. This goes great until the professor comes in and goes, "What the heck are you doing?" And my dad, in his surprise, inhales a mouthful of densely populated Staphylococcus aureus culture. The professor is like, "I'd usually fail someone for doing something this dumb, but you'll be getting enough punishment in about an hour and a half as it is. Get some Gatorade and brace yourself." Nothing like a healthy dose of staph toxin to teach you not to mouth pipette ever again. Yeah, this is pretty dumb. This is super dumb. I hope that the Staph aureus wasn't methicillin resistant, that's all I can say. Atomizing mercury story. Lab was using a meshed centrifuge. Undergrad was asked what the temperature inside of the centrifuge was. Guess what he did? He finds an ancient thermometer left in some random drawer, places it on the side, and lets it rip. He thought it would stick to the side. It immediately shattered and sprayed mercury all over the lab. This is a story told to everyone in our lab who asks why we only use thermocouples. This is a really valid point. I think you can mostly get away with thermocouples now. I'm not sure why people are still using mercury and alcohol thermometers. You can even calibrate a thermocouple, and if you don't need to be super sensitive and super exact, if you're okay to be within a couple degrees, you can get a thermocouple for like $3 on Amazon. It is super cheap. It usually does a better job, and it usually responds faster anyway, so I'm not sure why you'd use a thermometer in general. I just kind of thought it goes without saying, since every chemtuber seems to use thermocouples, that it doesn't need to be mentioned, but this is a good time to emphasize that if you can use a thermocouple for your chemistry, you should be using it. It's dirt cheap and it works well. Maybe it's not exact, but you don't know that your thermometers are exact either, and you never calibrate those, so you do you. This is today's big story. The safety inspector from my old university used to regale us about ye olden days, when waste disposal was taken much less seriously. Back then, everything went into the sink. Aqueous waste, organic waste, heavy metals, you name it. Toss it into the sink and it's gone. Of course, chemists will sometimes work with something foul or dangerous enough that even they hesitate pouring it into the sink. On those occasions, the waste would be pooled into a barrel, and when that barrel was full, it would be driven down to the harbor and dumped into the sea. Dilution is the solution to pollution. That may sound preposterous, but really, the only thing that sewers did back then was just lead the waste out into the sea as well. The only reason you would drive the waste down there yourself was because you'd spare the sewers the dangerous stuff, not because you'd spare the sea. Oh, we don't want to wreck the pipes. Who cares about the fish? Then, there were the rare compounds so unbelievably foul, so incredibly dangerous, that even dumping them into the harbor was too much for the chemist's conscience. For those select few items of waste, they would be collected in a small bottle and then given to the dean. You see, the dean would regularly need to travel to the capital, and the quickest way there would be to take a ferry. So the dean would bring the bottle of waste, then approximately at the halfway point, out on the open ocean, he would spill it over the side. This way you would spare both the sewers and the harbor. Problem solved. Oh, this is terrible. I'm really glad that we don't do this anymore, and if you know of anyone who does this, maybe you should tell someone about it. Don't put bad stuff down the drain, don't pour it into the harbor, and also please, don't pour it into the ocean. When I was taking chemistry in high school, my lab partner and I were always the first one to finish labs, so we would typically spend the rest of the period melting pennies and other random objects to kill time. You know, basic high school antics. Well, one day, we were doing the Reactive Metals Lab, which started by putting magnesium in water to make the hydroxide and hydrogen gas. Of course, the next step in the lab was to burn the magnesium using a Bunsen burner as the heat source. It lit up as normal, and we proceeded with the lab, skipping the step where we were supposed to turn off the burner. Obviously, this was a penny melting day. We move on to the sodium part. We were given small chunks to put in water and take note of how much more quickly the hydrogen gas was produced. We dropped the sodium in, watched it bubble and fizz for a few seconds, and then heard the teacher screaming, "Turn it off! Turn it off!" We looked back to our bench to see that the Bunsen burner's flame, only a few inches from the flask, had turned a red-orange color. A split second later, there was a characteristic "foomp" sound as the flame got sucked into the flask and ignited the hydrogen. Oh no! No one got hurt and nothing exploded, but it was still one of my favorite lab memories. One time I had a bit of diethyl ether in a flask, and I decided I would just flash it off instead of rinsing it with acetone. There was no point washing this flask because it had only had ether in it, so I was going to put it in the oven, but I didn't think it was a great idea to just put ether in the oven. And so I took a flame to it and foop! It was like a super foop, and it was hot, and the flask was hot, and I never did anything with ether near fire ever again. There was not enough ether in there to cause like a significant danger, but it is very dangerous to have an open flame in an organic lab. Don't repeat my mistakes. And maybe don't react sodium with water near an open flame either. That seems pretty stupid too. So I have one more story for this. One thing I used to do when I was growing up is I would melt Hot Wheels. Not Hot Wheels, but these like cheap knockoff brand Hot Wheels that weren't Hot Wheels, and they were mostly metal. This was like really cheap metal. And at one point in time, I figured out if I took a lighter to it, the plastic would burn, and it would get hot enough that all of the metal would melt. So for several weeks in a row, whenever I was bored, I'd go and I'd add a car to the pile, and I just had this big chunk of metal where all the cars had melted together. But one day, I decided that I'd try burning this plastic Mario Kart. And the plastic Mario Kart was something I'd got from like a candy store as like a little toy that came with candy. And so I figured this one has way more plastic. This one should burn way better. And it did. But man, did that burning Mario Kart stink. That Mario Kart smelled so bad. And my mom smelled it, and she's like, "You're not allowed to burn cars anymore. What the heck are you doing? This stinks. The whole house stinks. Outside stinks as well. You're not allowed to burn cars anymore." That was the end of my car burning phase. This is today's Yikes awardee. I used to work at a lab for PPE testing. Before I started there, one of the people working there got a chemical burn from pure HF gas. The glass tube used to connect the cylinder corroded till a hole formed. He had not noticed this and went to close the valve. As you can understand, a very bad time. While working there, I was more scared of the HF than the phosgene. Yeah, that's terrifying. Normally you have to use specialized passivated metal for anything you're doing with HF. I'm not sure why they would have had a glass adapter for the HF. That just seems like someone incompetent set that up. HF absolutely annihilates glass, and it is super dangerous, especially anhydrous HF. This was a biology class, but the worst thing I've ever seen in a lab was during the crawfish dissection unit in high school. Our teacher left the room for a bit, and one of the rowdier kids told his lab partners to dare him to eat the crawfish heart. The raw, formaldehyde-covered crawfish heart. They obliged him, and he popped the thing right into his mouth. Instant regret. I watched him start to gag, and run pell-mell into the hallway, right past our returning teacher, and hork into the hall trash. This is just stupid. I don't have anything to say other than this is a really stupid one. What is it about young guys and just doing the stupidest stuff ever? All of the dumb stories are like, there wasn't a good reason that it happened, but one of them dared them to, and so they did. Like half of Chubby Emu's videos are like that, where, oh, the guys decided to rub cream between their legs, and he absorbed the equivalent of like over 100 aspirin tablets. Why? Because his friend dared him to. It's so stupid. High school boys are so stupid. And when I was a high school boy, so was I. Not a chemist, but I love science. I work as an automotive technician, and let me tell you the importance of PPE, even when you yourself are not working on anything. I was walking towards my shop and had my safety glasses on my head, because after all, I wasn't in the shop yet, so I figured I wouldn't need them till I got to my workstation. As I was walking through the shop door, my eye suddenly stung like someone had just rubbed onions in my left eye. Thinking it was just a fume, I thought nothing of it and continued on. Later on in the day, my eye started burning again. This time, I was nowhere near where the incident occurred, and I had thought that something might be in my eye, so I went to the eye wash station to flush my eyes really quick, and it did provide relief for the rest of the workday. However, as I was driving home, it felt like someone had dragged a razor blade across my eye. What had happened was as I was walking through the shop door, a 2 mm long metal sliver had been flying through the air and embedded itself in my eye. In the 3 days it took me to get to an eye doctor, the shard had worked its way deeper into my eye, and the eye had already healed over the entry wound. Now, eye surgery of this level is some of the most stressful stuff. You have to sit in a chair perfectly still and stare at a single spot across the room, trying your best not to move or twitch your eye, as the surgeon takes a small razor-sharp spoon-like instrument to scoop out parts of your eye to remove all of the foreign object. You don't get put under, they just put a numbing agent on your eye, and you have to sit there perfectly still and either never blink, which is the fastest way to get through the procedure, or communicate with the surgeon when you're going to blink, so that they can pull the spoon out of your eye. Thankfully, I had no permanent damage to my eye, but if it had been less than half a millimeter to the left, I would have had permanent damage to my left eye. So yeah, always wear your PPE even if you're not working on something, and put them on before entering your shop or work area, or anywhere that is designated as PPE required. This is a terrifying story. I'm so glad that you didn't lose your vision, and even I have been in a shop before without wearing lab glasses, even though I was nowhere near anything. Little slivers of metal get everywhere, and when you have airflow out a door like that, it's easy for something to just get picked up and go flying, so you'd be better off wearing protective safety glasses for sure. I live in the European Union, so I can't get some stuff for amateur chem. So I have a long list of things that I can't get and how to make them from the stuff that I can get. No method is too weird for me to try if I need something. Example, I pissed on hay and straw and other plant matter daily for months to get some potassium nitrate. You can get your nitrate however you want, but I will pass. Have a great day.